All right, awesome young people, it's time to do the last of the 5 stoichiometry videos. This example is what I call a combination problem. It doesn't fit nice and neatly into a 1-step or a 2-step or a 3-step, and it's more than just a mole-mole problem. It's more than just a mole ratio problem. So if you watch the other 4 videos, those types of problems, they all have these nice, neat little categories. This one is a little bit messier, and I'll show you how to use the mole diagram to guide you. But here we go. Let's read this for our givens and our unknowns. How many liters of H2O, that's water, are produced at STP from 15 moles, and oxygen gas, that's O2, right? That's oxygen gas, is this one up here. You'll notice that there's a balanced chemical equation. And you'll notice that you've got liters and you've got 2 different chemicals. It looks a lot like a 3-step mole problem. The difference here is this one. It says moles. It's giving you moles right away. So you don't have to calculate moles like you would if it was a 3-step problem. So there we go. I'm going to write down these things and then I'll show you what to do with the mole diagram. 15 moles O2, that's my given. And my unknown is liters of H2O. There. All right, so now let me show you what to do with the mole diagram. All right. Instead of starting on the outside of the diagram, turns out I'm starting for this one at moles. And that's specifically, that's moles of O2, right? That's our given. And so I'm going to have to use the mole ratio. That'll give me moles, but that's moles of my new chemical. And then finally, I'm trying to get over to liters, so I'm going to have to do this relationship up here. And that will get me to liters of H2O. And it said liters H2O at STP. So if I have this mole diagram in front of me, I can actually map out my strategies. If you don't have it in front of you, this would be a really handy thing to be able to memorize so that you could draw it for yourself for the final exam. All right, I've got my strategies. Do you notice how I have 2 arrows? That means 2 strategies. That means 2 mathematical relationships. Let's go ahead and write those out. The first relationship is going to be my mole ratio. And remember, I always start with the unit and the chemical of my given. So it's going to be moles of O2. And I know that I'm going to be changing to moles of H2O. Where do I get the numbers for my mole ratio? Let's go back to the original problem real quick. That comes from the coefficients up here. 6 goes with oxygen, and 4 goes with water. Great. My second relationship, I have to go from moles of H2O. I always start my moles of H2O here because I ended with moles of H2O in my first relationship. So moles of H2O, and I'm trying to get liters, right? So the magic number that goes with liters at STP is 22.4 liters. And remember, I can either change the chemical or I can change the unit, but I can never change both at the same time. And if I'm changing the chemical, like from oxygen to water, I have to have moles to moles. What do I put here for the number for moles? Do I use 4? I've already used it, so no. It's always going to be 1 mole for my relationships, unless it's the mole ratio. Sometimes the mole ratio has other coefficients other than 1, but if it's not the mole ratio, then it's going to be 1 mole. There's my 2 relationships. Now I can go ahead and I can do my fractions. First fraction is my given fraction, 15 moles O2. put it over 1 to make it a fraction if you wish. And I have 2 relationships, so that means I'm going to need 2 new fractions in order to solve my problem. Now, this one right here, which one goes on top, which one goes on the bottom? I don't even have to think about it, do I? Moles O2 from the numerator, I can put moles O2 in the denominator of the next fraction. Now I know that 6 goes on the bottom and 4 goes on the top. Moles of H2O goes with 4. And I can take that and I can put moles of H2O down here. From my next fraction, 1 mole H2O, that was 1. What goes on top? 22.4 liters H2O. And there you go. You've got it all set up. Moles cancels moles. O2 cancels O2. Moles, moles. H2O, H2O. And that leaves you with liters H2O, which should be exactly what you have for your unknown. So when you calculate all this in your calculator, right, when you put this all in your calculator, you should get, mathematically, 224 liters of, whoops, not O2. How do I know it's not O2? Because guess what? That's not my unknown. H2O. And there's my answer to this question. So folks, combination problems are just like 3-step mole problems, except you don't have to get moles first in order to solve it, because they gave you moles already. When you use the mole diagram, let me go back to that one more time, just use the mole diagram to guide you. Start wherever your given is, put your other finger wherever your unknown is, and then trace from one to the other and pay attention to which arrows you're crossing. That will tell you which relationships you need. Thanks for watching.